Okay, day 3 homework. Okay, when you're using a table of ordered pairs, if we substitute and say x is equal to 0, we'll have 0 plus 2y equals 6, so y equals 3. So our first ordered pair is 0, 3, which is 1, 2, 3 right there. All right, when y is equal to 0, we have 3x plus 0 equals 6, so x is equal to 2. So our ordered pair is 2, 0. So that's right there. And finally, when y is equal to negative 2, we have 3x plus 2 times y is equal to 6. So 3x minus 4 equals 6. 3x equals 10. So x equals 10 thirds, or about 3 1/3. So our ordered pair here would be 3 1/3, negative 2. That's a tough one to graph. But let's see, 3 and a little bit more than a 1 and negative 2 would be about there. Okay, so we would graph this with a straight edge, which I don't have, and it would be like that. Okay, number 2, x minus y equals 6. So when x is equal to 2, we have 2 minus y equals 6, so negative y equals 4. So y equals negative 4. Our ordered pair is 2, negative 4, which is 1, 2, 3, 4 right there. Okay. When x is equal, or y is equal to negative 3, we have x minus a negative 3 equals 6. So that's x plus 3 equals 6. So x equals 3. So our ordered pair is 3, negative 3, which is 1, 2, 3 right there. Okay, and finally, when y is equal to negative 2, we have x minus a negative 2 equals 6, so x plus 2 equals 6, so x equals 4. Our ordered pair here is 4, negative 2, which is right there. So our graph would be that line there. Okay, if you're going to use the intercept method, to find the x-intercept, you set the y equal to 0. So you have 4x equals 12, so x equals 3. That's the x-intercept. To find the y-intercept, you set the x equal to 0. So you would have 3y equals 12, so y equals 4. And that's 1, 2, 3, 4. That's the y-intercept. So you could graph like that. All right, number 4, to find the x-intercept, we're going to set the y equal to 0. So we're going to have 5x equals 15, so x equals 3. And then to find the y-intercept, we're going to set the x equal to 0. So we'll have 7y equals 15, so y equals 15 over 7, or 2 1/7. Now that's a little hard to graph, but it's a little bit more than the 2, not much more. And there's our graph. So the intercept method works really well when these coefficients both go into this without a remainder, and it doesn't work so well when that doesn't happen. All right, number 5, we want to find the midpoint of negative 8, negative 12, and 8, 16. So the midpoint is the midpoint of the x's is x1 plus x2 over 2. That's just an average. So this is negative 8 plus 8 over 2, which is 0 over 2, which is 0. The y value, the midpoint of the y value, is the same thing, but for the y's. And in this case, it's negative 12 plus 16 over 2, which is 4 over 2, which is 2. So this what the point we're after is 0, 2. Okay, so here the x value would be x1 plus x2 over 2, which is 0 minus 9 over 2, which is negative 4.5. And the y value for the midpoint would be the same thing for the y's, which is negative 5 plus 8 over 2, which is 3 over 2. You can leave it as 3 over 2. I prefer to have it a mixed number so it's easier to graph if it's necessary to graph. Either way, it's okay. But to put it in an ordered pair, it's like this. Okay, so I'm just going to, the x value of the midpoint is the x values added up, divided by 2, that's 5.2 over 2, so that's 2.6. The y value of the midpoint is 8.6 plus 15.2 over 2, which is 23.8 over 2. What is that? That's about 11.9, I believe. So the value that we're after, the midpoint in an ordered pair, is that. Okay, so the value of the x midpoint is 15.5 plus a negative 6.5 over 2, which is a 9 over 2, which is 4.5, and the y value is negative 6.3 minus 12.7 over 2, which is 1819 over 2, which is a negative 9.5. So the ordered pair is 4.5, negative 9.5. Okay, the slope is the change in the y values. Well, let's do it like this. It's the rise over the run. The rise is the change in the y values. The run is the change in the x values. The change in the y values is the difference of the y values, and the change in the x values is the difference of the x values. So, if we have 2 points, and the points are negative 1, 2, and 4, negative 6, this is our x1, and this is our y1. If this is point 1, you can label the points anything you want. If this is point 2, then this is our x2, and this is our y2. Okay, so looking at this, our y2 is negative 6 minus our y1, which is 2, over our x2 is 4 minus our negative 1, so that's like a plus 1. So this is a negative 8 over 5. So the slope is negative 8/5. Okay, number 10, this is in a slope-intercept form. Remember, slope-intercept form is y equals mx plus b. This is our slope, so our slope is 2. Okay, number 11, this is in standard form. When you have something in standard form, the shortcut is the slope is always equal to negative b, or a over b, excuse me. Okay? Now, if you remember that, you can see right away that we have a slope of 3/4 here. It's a negative a over b. But if you don't remember that, you have to put this into slope-intercept form. So you do that by moving this term over here so that you have 4y is equal to 3x plus 5, and then dividing by 4, which is 3/4 x plus 5/4, and this is your m. So you'd still get m as 3/4. Again, if you notice that this was in standard form and you knew this little trick there, you can jump right to the slope. Okay, number 12, y equals 4 is a horizontal line, but you can think of this as y is equal to 0x plus 4. There's our slope, so m is equal to 0. That's a horizontal line. Okay, number 13 wants a line parallel to this. So let's put it in slope-intercept first by dividing by 3. So the slope is negative 2/3. That means the slope of any line parallel to this is also negative 2/3. Okay, here let's put this into slope-intercept form. Or, this is already in standard form, so if you know that m is equal to negative a over b, this is going to be a positive 3. That's what the slope is. So the slope of any perpendicular line is the opposite reciprocal. So there's the... Okay, number 15, this slope goes up to the right, so it's positive. It goes up from left to right. Okay, number 16, this slope goes down from left to right, so the slope is negative. Okay, this slope is horizontal, so it has a slope of 0. Oops. Okay, number 18, this is a vertical line, so this is an undefined slope. That's because if you did the rise over the run, you'd be running 0, so you'd be dividing by a 0. So it's an undefined slope. Okay, number 19, slope is equal to the rise over the run, or the change in the y over the change in the x. So we're rising 1 foot for every 4 feet of run, so the slope is 1/4. So if we say that the slope is 1/4, and in this case we're going to be rising 3 feet, how many feet will we run? Well, we can simply cross multiply, and x would be 12 feet. So we would this would correspond to a 12 feet in the horizontal direction. Okay, number 24. This is an undefined slope, so we know that this is a vertical line, so we know it's going to be an x equals. And here's our x value, so x equals 2 is our final answer. Okay, so think of the line y equals mx plus b. This is our slope, which they show us, and this is our y-intercept, which they give us. So y would be equal to negative 1/3 x plus 5. Okay, number 22. Think of the slope-intercept form, y equals mx plus b. This right here is the slope, which they give to us. So this is negative 1/3. And this right here is the y-intercept, which they give to us. So this would be 5. So the equation would be y is equal to negative 1/3 x plus 5 in slope-intercept form. Okay, they want an equation of this line. It's undefined. When it's undefined, you know it's an x equals line. That's a vertical line. And this is a 2. So x equals 2 is the final answer. Okay, so for number 20, they're talking about income and time. And if you think of an axis, we can call this the time axis. This would be our x-axis. And this would be our income. That's the y-axis. And so this is our rise, and this is our run. All right, so when you think of the slope, this is the rise over the run, and the change in the y values is going to be 56,200 minus $21,000. That's the change in the y values. And the change in the x values is from 2005 to 1980. So this is going to be 35,200 over 25 years. So this would give us a slope of 1408. And if you labeled this, would be dollars per year. Okay, number 21 wants it in slope-intercept form. So slope-intercept form is y. Let's do this in a different color. Y equals mx plus b. This is our slope. And they give us our slope, so that's 3/5. And this is our y-intercept, which they give to us, which is -8. So the equation would be y is equal to 3/5 x minus 8 in slope-intercept. Okay, again, y is equal to mx plus b. Our slope is here, so that's -1/3. Our b, our y-intercept is here, so that's 5. So our equation would be y is equal to -1/3 x plus 5 in slope-intercept. Okay, y equals mx plus b. Our slope is 0, and our b, our y-intercept, is 12. And so when we do this, we're going to have y is equal to 0x plus 12, or in other words, just y is equal to 12. Okay, for number 24, we have an undefined slope. An undefined slope is a vertical line which is always in the form x equals a number. And when we look at this, our x value is 2. So x equals 2, and we're done. Okay, a horizontal line is always in the form y equals. And if we look, our y value is there, so we're done. Y equals 4, and that's our final answer. Okay, a vertical line is always in the form x equals. We have our x value here, so x equals 0.3, and we're done. Okay, this wants our line first in slope-intercept form, so we need a slope. So our slope is our change in our y's over our change in our x's. So the y2 is 4 minus a -5 over 1 minus 2. This is 4 plus 5, which is 9. 1 minus 2 is -1, so that's -9. So let's put it into point slope form. Since we have a point, here's a point, choose either one, and we have a slope, we'll put it into point slope form. So our point slope form is y minus y1 is equal to m times x minus x1. And we'll substitute the subscript values with our point. So y minus a -5 is equal to -9 times x minus 2. So y plus 5 is equal to -9x plus 18. So y is equal to -9x plus 13. That's slope-intercept form. Now to put it into standard form, we move our 9x over to the left. And we would get a positive 9x plus y is equal to 13. And that's part B, standard form. This was part A. Again, our first step here is going to be to find the slope. So the slope is the y2, which is 6, minus y1, which is 1, over x2, which is 2, minus -3. So we have a 6 plus 1, or 7. 2 plus 3 is 5, so our slope is 7/5. Now in point slope form, we say y minus y1 is equal to m times x minus x1. So, and we'll pick either point, it doesn't matter. Let's pick this one this time. So we'll say that y minus 6 is equal to 7/5 x plus 3. Oh, what did I just do? Plus 3. X minus 2. Well, I looked at the wrong point. X minus 2. Okay, now I'm going to distribute on the right. So we have y minus 6 is equal to 7/5 x minus 14/5. And finally, I'm going to add the 6 to each side. So y is equal to 7/5 x. Let's do this. I'll put minus 14/5 plus 30/5. This is 30/5. Okay? And so I'll get y is equal to 7/5 x plus 16/5. This is slope-intercept form, and that's part A. All right, part B. We're going to put it into standard form. The first thing I'm going to do is multiply everything by 5 to clear my fractions. 5y is equal to 7x plus 16. Then I'm going to move my x over to the left. So negative 7x plus 5y is equal to 16. Finally, I'm going to flip everything so that my first term is positive. So 7x minus 5y is equal to negative 16, and that's standard form. That was part B. Okay, parallel to this and through this. So the first thing, let's find the slope of this line. So I'm going to move my 4x over to the other side. So I have negative y. I'll just do it right here. Negative y is equal to negative 4x plus 3. So y must be equal to a positive 4x minus 3. So this tells me that my slope of this line is 4, the number in front of the x. That tells me that the slope of any line parallel to this is also 4. So now I have my slope. And now I'm going to use this point and this slope to put it into point slope form. So y minus y1 is equal to m times x minus x1. So y minus a negative 2 is equal to 4 times x minus 6. That's using that point and that slope. So y plus 2 is equal to 4x minus 24. And that's the line in, and we got to move this 2 over by subtracting it. So y is equal to 4x minus 26. So that's part A, slope-intercept form. For part B, I'm going to move my 4x over to the other side. And I'll get negative 4x plus y is equal to negative 26. But I want my A term to be positive, so I'm going to flip everything, and I'll end up with a positive 4x minus y is equal to a positive 26. And that's standard form. Okay, perpendicular to this line. So let's first find the slope of this line. So I'll move this over. So I have negative 5y equals negative 2x plus 7. And so y is equal to a positive 2/5 x minus a 7/5. So our slope of this line is 2/5. But the slope of any line perpendicular to this is the opposite reciprocal, so negative 5/2. Now I'm going to use this slope and this point. And I'm first going to put it into point slope. So I'll have y minus 1 is equal to negative 5 halves x minus 0. So y minus 1 is equal to negative 5 halves x. Let me move the 1 over. So I have y is equal to negative 5 halves x plus 1. And that's part A, slope-intercept. Now to put it into standard, I'm going to first clear the fractions by multiplying by 2. And then I'm going to move my 5x to the left, and I'll get a positive 5x plus 2y is equal to 2. And that's part B, standard. This is part A. Okay, for part A, we've got y, this is for part A, is equal to $57 per month, so 57x plus the one-time fee of $159. So if we want to talk about the cost of 1 year, we're going to substitute 12. So we're going to say y is equal to 57 times 12 plus 159, and this just takes a little bit of arithmetic, but you're going to get $843. Okay? For part B, it's y is equal to, and it's $47 a month plus that 159 fee. So again, if we talk about 1 year, we'll say 47 times 12 plus 159, and this should come out to $723. Page 261, numbers 1 through 11, skipping number 8. Okay, number 1, slope is the change in the y's over the change in the x's. So we've got negative 1 minus 4 over negative 4 minus 6, which is negative 5 over negative 10, which is 1/2. Okay, number 2, to find the x-intercept, you're going to set the y value equal to 0. So you will end up with 3x equals 13. And so x is equal to 13 over 3. Now if you put that into an ordered pair, and remember y is equal to 0, you have 13 over 3, 0. That's the y-intercept, or the x-intercept. To find the y-intercept, you set the x equal to 0, in which case you're going to have negative 2y is equal to 13, so y is equal to negative 13 over 2. And again, the x this time was 0, so our ordered pair is 0, negative 13 over 2. I forgot to find the slope of the last problem in the last slide, so let's do it here. If you this is already in standard form. If something's in standard form, if you remember, the slope is negative a over b, so this is going to be 3/2. Okay? If you don't remember that, you have to put it into slope-intercept form. So to do that, I'm going to move the 3x over, so I have negative 2y is equal to negative 3x plus 13. So y is equal to a positive 3/2 x minus 13 over 2. And there's our slope, 3/2. Okay, so in this problem, if you think of this in slope-intercept form, 0x plus b, our slope is 0. All right, and if you think about what this looks like on a graph, y equals 5 looks like this. So there, the y-intercept, what do they want first? They want the x-intercept first. There's none. It doesn't cross the x-axis. The y-intercept, of course, is 5. Or you could say as an ordered pair, it's 0, 5. And there's our slope. Number 4, the graph of a line with an undefined slope is a vertical line. I can't write. Vertical line. That's an L and an E. Okay, to find the x-intercept, we're going to set the y value equal to 0. And so we're going to say that 4x is equal to negative 12, so x is equal to negative 3. And we go to negative 3, 1, 2, 3, and we graph a line. To find the y-intercept, we're going to set the x equal to 0. So when x is equal to 0, we have negative 3y is equal to negative 12, so y is equal to positive 4. And we go 1, 2, 3, 4, and we graph a line there. And our graph will look like this. Make sure you use a straight edge. Okay, in this problem, if we solved, we would get y is equal to 2. So that's obviously our y-intercept. And this is going to be a horizontal line, so the x-intercept, there is none. And it's going to be a horizontal line going like this. Okay, so the y and x intercepts are both 0 because this goes through the origin. If you don't see it, just set the x equals 0, then y is equal to 0, that's the y-intercept, and set the y equal to 0, and then in which case negative 2x equals 0, so x equals 0, so that's the x-intercept. So that goes through the y-axis. Now, let me grab this graph. Okay. In this problem, y equals mx plus b, so our slope is negative 2, and it's going through the origin. So we're going to go down 2 and run 1. This is like a 2 over 1. And we'll graph this. Again, use a straight edge. There you go. Okay, if you want to find the x-intercept, we'll set the y equal to 0, and we'll say that 3x, well, it changes to an equals. So x equals 2, that's the x-intercept. And then to find the y-intercept, we'll set the x equal to 0. So negative 2y, I'll change that to an equals. So y is equal to negative 3. And then when you graph this, well, I'm going to put this into slope-intercept form. I know that the graph is going to look like this. It's going to be a dashed line because of the greater. But I don't want to make a mistake on which way I shade it. So I'm going to solve this for y. So I have negative 2y is greater than negative 3x plus 6. I divide by negative 2 and I get y is less than, because I'm dividing by a negative, 3 halves minus 3. So I can see that I'm shading the lower side, the less than side of this, which is why I wanted to put it into slope-intercept form so I didn't accidentally shade the wrong side. Okay, number 9, you want to put this in standard form. There's a line going through these points, so let's first find the slope. That's y2 minus y1 over x2 minus x1. This is going to be negative 5 over negative 6 plus 3 is negative 3. So that's 5/3. And then let's put this in point slope form. Pick either point. It doesn't matter which one. Okay, I'll pick that one. So I have y minus y1 is equal to m times x minus x1. X minus negative 6 is x plus 6. I'm going to distribute that 5/3. Well, 3 goes into 6 twice, so this will become a 10. And then I'm going to add my 9 to each side. And this is slope-intercept form. But if you want it in standard form, now we're going to have to get rid of our fractions by multiplying everything by 3. I'm going to have to move my 5x over. And then I don't want my x to be negative, so I'll flip the sign of everything. And that's standard form. Okay, so here we already have a slope, so we're ready to go right into slope, point slope form. So y minus y1 is equal to m times x minus x1. So y minus negative 1 is plus 1. Negative 5 times x minus 4. So y plus 1 is equal to negative 5x plus 20. Now, if I want to put this into standard form, which is what it's asking for, I got to move this way and this way. So I have 5x plus y is equal to 20 minus 1, which is 19. That's standard form. Okay, now we're finding a line that's through that point, negative 7, 2, and parallel to that other thing. So let's first start with this and find the slope of that by putting into a slope-intercept form. So I'll move my 3x over, and I'll get 5y is equal to negative 3x plus 6. So y is equal to negative 3/5 x plus 6/5. So our slope of this line is negative 3/5. That means the slope of any line parallel to this is also negative 3/5. And we could have found that by doing negative a over b without doing all of that. Okay, now let's put this into a point slope form. So we have y minus y1 is equal to m times x minus x1. So y minus 2 is equal to negative 3/5 times x minus negative 7. That's a plus 7. If I want this in standard form, let's distribute that negative 3/5. So I have y minus 2 is equal to negative 3/5 x minus 21/5. I'm going to clear my fractions by multiplying by 5. So 5y minus 10 is equal to negative 3x minus 21. And now I'm going to move my 3x this way and my 10 this way. So I get a positive 3x plus 5y is equal to negative 21 plus 10 is negative 11. This is standard form. And does it ask for just standard form? Oh, it wants it in slope-intercept form. Great. Okay, I was better off at this point. Well, let's see. I'm just going to squeeze it in over here. So I'll move my 3x over, so I have 5y is equal to negative 3x minus 11. And now I'll divide by 5. And so I'll say y is equal to negative 3/5 x minus 11/5. That's slope-intercept form. It would have been easiest to go from this point right here and get that. Number 12, y equals 2x. Our slope of this line is 2, the number right in front of the x. That means that the perpendicular is the opposite reciprocal. Well, this is like a 2 over 1, so this is going to be a negative 1 over 2. So now we have a point and a slope. So let's put this into point slope form. Y minus y1 is equal to m times x minus x1. Let's bring this up here. Y minus 2 is equal to negative 1/2 m minus negative 7. X minus negative 7, excuse me. Minus a negative 7 is plus 7. I want this in slope-intercept form, is that right? Yeah, slope-intercept form. So now I'm going to distribute that. Y minus 2 is equal to negative 1/2 x minus 7/2. And now I'm going to move my 2 over to the other side. So I have y is equal to negative 1/2 x. Let's do it like this. Minus 7/2 plus 4/2. That's what 2 is, 4/2. And so I'm going to end up with y is equal to negative 1/2 x minus 3/2. Page 265, numbers 1 through 20. Number 1, the absolute value of any number is always positive. The additive inverse of a negative number is also always positive. So this statement is always true. Okay, the word rational number comes from the word ratio. Any fraction is a ratio. So as long as you had any number, like say 5/4, as long as this is not a 0, which would give an undefined fraction, any fraction is always a rational number. So this is always true. All right, let's clean up the absolute values first. So here we have a negative. This becomes a positive 2, minus 4. This becomes a positive 3, so we have a plus 3, and this becomes a plus 7. So negative 2 minus 4 is negative 6, plus 10 is 4. Okay, the negative is inside of the parentheses. It's being squared, so that's going to be positive. 8 squared is 64, and we'll move the decimal place back 2 places. So 0.64 is our final answer. Okay, we cannot take the square root of a negative number. At least we can't do it and get a real number. So this is not a real number. Okay, first of all, a negative times a negative is a positive. Now we're going to cancel. 3 goes into 12 4 times, and we'll multiply across the top. 2 times 4 is 8. 3 times 1 is 5, and negative times negative is a positive, so 8 fifths. Okay, we're going to multiply and distribute this negative in, and it's going to give us a positive 4m and a negative 3, so 4m minus 3. Okay, let's combine like terms. Here we have a positive 3 and a negative 1x squared. That adds up to a positive 2x squared. Then we have a negative 4x and a positive 9x. That adds up to a positive 5x. And finally, we have this positive 4, and that just is all by itself. So our final answer is 2x squared plus 5x plus 4. Okay, square root of 16 is 4. So up top we have 3 times 4. Minus negative is a plus 1 times 7. Over, we have 4 plus negative 6 is a 4 minus 6. Okay, so now up top we have 12 plus 7 over negative 2. That's going to give us 19 over negative 2. And let's bring that negative out. So we have negative 19 over 2. Final answer. Okay, we want to put this in interval notation. So there's a less than on the 3, so we have negative 3 with the parentheses, but there's an equal sign on the 5, so that's going to be a bracket, and that's the answer in interval notation. Okay, number 13, it's asking if this is a real number. So let's take a look. On top, we have a positive 2. On the bottom, we have a negative 5. So we have the square root of a negative number, and we can't do that. So no, this is not a real number. Okay, we've got here negative 3 times 2q. Oops, this is a q here. So that's times negative 2 minus 3 times 4. So this is negative 3 times negative 4 minus 12, or negative 3 times negative 16, So the answer here is 48. Okay, so we have the absolute value of 4 cubed minus the absolute value of negative 2 cubed. Okay, so this is going to be 4 cubed, which is 64, minus the absolute value of negative 2 cubed is negative 8, which is 8. So 64 minus 8 is 56. Okay, here we have the square root of 5 over negative p, so negative 4 plus 2 times negative 2. So this is the square root of 5 over negative 4 plus 4, which is the square root of 5 over 0. So this is an undefined fraction. So the answer is undefined. Okay, let's combine like terms on the right hand. By the way, this is number, this is number 17. Let's combine like terms on the left-hand side, and we're going to get 2 plus 3 is 5z minus 5. We'll distribute this negative here and get 4 minus z minus 2. And when we combine those, we'll get 4 minus 2 is a positive 2. Okay, so I'll move the z over here by adding it. I'll move the 5 over there by adding it. And we'll get divide by 6, so we'll get z is equal to 7 over 6. Okay, number 18. I think the easiest thing to do is to decide to get rid of the fractions first. So I'm going to get the LCD, which is 10, and I'm going to multiply everything by 10. So I'll multiply this fraction by 10, this fraction by 10, and this fraction by 10. And then I'm going to cancel. 5 goes into 10 twice, and I'm going to multiply to get 6a minus 2. Over here, I'm going to say 2 goes into 10 5 times, and I'm going to multiply to get a positive 5a plus 10. And here, 10 goes into 10 once, and I multiply negative 3 times 1 is negative 3. So now I'll combine like terms. This and this add up to 11a. And this add up to a positive 8. I'll add 8 to each side. Negative 3 plus, or excuse me, I'll subtract 8 from each side and get negative 11. Negative 3 minus 8 is negative 11. And I'll divide by 11 on each side, and I'll get negative 1. Okay, we're solving this for h. The first thing I would do is get rid of the fractions by multiplying 3 on each side. And that cancels these. And I'm going to have 3v equals pi r squared h. And then I want to isolate the h, so I'm going to divide each side by pi r squared. And everything on the right will cancel. So I'll have h is equal to 3v over pi r squared. Okay, when two things start at the same place and go in opposite directions, let's say one goes this way and one goes this way. At the end of the time, if we know that the distance between them is 2,100 miles, we know that this distance, let's say A plus B, add up to 2,100 miles. Okay, so let's make a heading here. One travels east at 5:50 and the other travels west, and they're going to be going for X hours. So the distance the first plane goes is its speed times the number of hours. The distance the second plane goes is its speed times the number of hours. So if we add these two things up, we're going to get 2,100 miles. So this is 1,050x equals 2,100. So x is equal to 2. It says how long. X is the number of hours. So this is 2 hours.